Hey everyone. In this video, I want to show you how I use generative AI to help students get better at preparing for their assessments. So let's start with where students usually get their assessment info. Most of it comes from two documents, the course outline and the assessment description. The course outline is available at the start of the term, and the assessment description usually comes later. Now, these documents often tell you two things. First, what the assessment is trying to achieve. That's the learning outcomes. And second, what students have to do, the actual tasks. But here's the problem. They almost never tell you what skills you need to complete those tasks. And that's a big issue, because if students don't know what skills are needed, how can they prepare properly? So to help with that, I looked at what we do have access to, the course outline. Even though it doesn't have all the assessment details, it still gives us a good starting point. And this is where Gen AI can really help. It can read the course context and the learning outcomes, then figure out what skills are likely needed for each assessment. From there, the AI can suggest support services that match those skills. So if a student sees they're missing something, they know exactly where to go to get help. All right, let's talk about where this data comes from. You can find course outlines easily on the university website. Each one usually has 7 parts: general course info, course details and outcomes, assessments, the course schedule, resources, staff details, and other helpful info. There's no simple way to download all of this across different courses, but I used a basic web scraper to collect the data for this demo. Don't worry, I've changed the real course codes to keep things anonymous. What I ended up with was a nice, structured format where you can see learning outcomes listed under each assessment. That structure is super helpful for analysis. Now that we have the course outline data in a format we can work with, here's the plan. Instead of jumping straight into mapping everything to general skills, which can make us lose important context, we focus first on pulling out the assessment-specific skills. These are the actual skills a student needs to do well in a particular task. This is really important, because once a student knows what skills are expected, they can check for any gaps and work on them early. That's the first goal here, to help students identify what skills they need. The second goal is to help them close those gaps. So after we get those assessment-specific skills, we group similar ones together. To do this properly, we need something called a skill taxonomy. Basically, it gives us categories that make sense across different assessments. These categories help us connect the skills to support services. So now, instead of just saying, you need to improve this skill, we can actually say, here's a workshop or resource that can help you improve this exact skill. In the end, the goal is simple. Help students understand what their assessments are asking for, figure out what skills they need, and give them the right tools to succeed. All right, so the next step is to actually extract the skills for each assessment. This is where things get interesting. We use Gen AI to pull skills from 2 main places, the assessment description and the related learning outcomes. And we were really clear with our instructions. These skills had to be specific to each assessment. No vague, general skills allowed. So instead of broad terms like communication, we were looking for more concrete, course-specific versions of that skill. For example, if an assessment required students to pitch a marketing plan, the AI might extract persuasive presentation delivery or visual storytelling tailored to a business audience. Much more specific and way more helpful for students trying to figure out exactly what they need to work on. And honestly, the results were pretty impressive. Even with limited information from the assessment description, the AI was able to pick out relevant, practical skills that make total sense. Like, if the task was a video presentation, it identified video editing and visual storytelling as needed skills. If it was a timed exam, it brought up time management. These are the kinds of details that actually help students figure out what they need to work on. So now, for each course, we have a nice little summary that includes what the course is about, the name of the assessment, and the list of skills Gen AI extracted for that assessment. And this is a big step forward, because now students can see clearly which skills are tied to which tasks. No more guesswork. But of course, we're not stopping there. Like I mentioned earlier, to really make these skills useful and to connect them to things like support services, we needed a proper skill taxonomy. So we did our homework, a lot of homework. We reviewed a bunch of well known frameworks covering everything from job skills to education, digital capabilities, and even future workforce trends. Some of the big names we looked at were Winnett, ESCO, Bloom's Taxonomy, SFIA, Lightcast, the NICE framework, and the WEF Future Skills Taxonomy. Since our focus is on education, we decided to go with a hybrid approach. We pulled the most relevant pieces from ESCO, WENT, Bloom's, and WEF's taxonomy and combined them into a structure that works for both learning and career pathways. The final result? A taxonomy that organizes skills into four main areas. First, we've got cognitive and learning skills. These include things like research, problem solving, and creativity. Basically, all the brain power stuff. Then there's workplace and soft skills, things like communication, teamwork, adaptability. The skills that help you actually work with other humans. Next up, digital and future skills. These are all about being tech savvy, AI, data, cybersecurity, and digital literacy. And finally, industry-specific skills. This bucket includes more targeted expertise in fields like business, STEM, healthcare, and finance. By organizing the skills this way, we can connect task-specific skills to broader skill categories. That helps us match students with the right resources, whether that's a workshop, a tutoring session, or something career-related. All right, now that we've got this solid skill structure, the next step is to cluster those assessment-specific skills and then connect them with support services. But before we can do that, we need to figure out where each of those skills fits within our taxonomy. In other words, it's time for skill clustering. This means taking all the specific skills we pulled from assessments and mapping them to the broader categories in our skill framework. And there are basically two ways to go about it. One way is to just ask Gen AI to do the mapping directly. You give it the categories and ask, which one does this skill belong to? Simple, right? But there's a catch. While this method is easy to understand, it can be a bit unpredictable. Large language models can sometimes be inconsistent. They might map the same skill differently depending on the prompt or the context. Not exactly what we want when we're aiming for accuracy and fairness. The second approach is a bit more technical, but it gives us better results. Instead of relying on AI guesses, we use embeddings, basically mathematical representations of the skills and categories. Then, we measure the cosine similarity between them to see how close they are. The closer the score is to 1, the more similar they are. We set a threshold of 0.8. If the similarity score between an assessment skill and a taxonomy category is 0.8 or higher, we consider it a match. If it's below 0.8, we treat it as unmatched and take a closer look. Let me show you how this works with a real example. In this political science course, there's a major essay assignment. One of the skills Gen AI pulled from this task was critical evaluation of political debates. When we ran the similarity check, this skill matched with the broader category research and analysis under cognitive and learning skills with a score of 0.83. That's above our threshold, so it's a good, solid match. Now let's look at a case where things didn't go quite as smoothly. We had another skill from the same course, reflection on future challenges in US politics. The model initially mapped this to cybersecurity awareness, which, doesn't quite fit. The similarity score was 0.79, just under our threshold. Now, since it's close, this is where Gen AI can still be helpful. We took another pass and asked it to reconsider the mapping. This time, it placed the skill under research and analysis in the cognitive and learning skills category, which makes a lot more sense for a reflective, analytical task in political science. So this two-step process, automated matching first, then manual review for edge cases, gives us the best of both worlds, accuracy and flexibility. Now that we've finished mapping all the skills, let me show you what it actually looks like, because sometimes a good visual makes everything click. We've created a visualization that shows how the assessment-specific skills are clustered based on the skill categories they were mapped to. So for example, take the skill Research Skills for Academic Sources, which came from the Environmental Hazards Explainer assessment. That one was mapped to the Research and Analysis group under the Cognitive and Learning Skills category. Each skill is represented as a data point, and the points are color-coded based on which skill category they fall into. So you'll see red for digital and future skills, purple for workplace and soft skills, and other colors for the rest. It gives you a quick sense of how skills are distributed across categories. Now here's where it gets even more useful. You can filter the chart in a few different ways. First, you can filter by skill category. In this view, I've selected all the skills that fall under STEM and technical, which is part of the industry-specific skills group. This gives a focused look at all the technical skills tied to assessments across different courses. Alternatively, you can filter by course. So let's take a look at one course here. You'll notice that its skill profile is pretty diverse. Most of the assessment skills fall into cognitive and learning skills and workplace and soft skills. But there's also one mapped to an industry-specific skill. This kind of view is really helpful. It shows that while some courses focus on a narrow skill set, others spread across multiple categories. So not only does this visualization help us understand what skills are being developed, it also shows how balanced or unbalanced each course is in terms of skill development. Okay, now that we've got our skills nicely mapped to categories, we can start thinking about how to connect those categories to real-world support that helps students grow those skills. But here's the thing, we're not matching services to individual assessment tasks. Instead, we're linking them to the generic skill categories from our taxonomy. And there's a good reason for that. By mapping services to broader skill areas, we make them relevant across different courses and assessments. Because let's face it, if a student is struggling with, say, academic writing or time management, it's probably not just in one course. It's likely showing up in multiple places. So this approach makes it easier to reuse the same support service for a wider range of needs. And it helps the university make better use of resources too. But even though we're mapping to general categories, we still want the AI to understand the specific ways each service can help with real tasks. So, we included a lot of detail in the service descriptions, things like what the service offers, which skills it targets, and how students can access it. Here's a quick rundown of the 6 services we included. The Postgraduate Support Service helps postgrad students build study habits, manage their time, and stay focused on academic goals. Psychology and Well-Being Services provide free mental health support to help students manage stress and stay on track. Mathematics and Physics Support offers one-on-one or group help for students studying first-year or engineering-level math and physics. Academic Language and Learning Support helps students improve their writing, presentations, referencing, and general study skills. And finally, the course convener is the go-to person for subject-specific questions, industry insights, and assessment-related support. And that's just a sample of what's available. Each of these services has been thoughtfully mapped to our skill categories, so students don't just know what they need to improve, but where to go to work on it. All right, with our support services now connected to skill categories, we've built a full pipeline, from understanding the assessment to identifying the skill gaps to finding the right help to close them. So what does this all look like when we put it into practice? Let's jump into that next. Okay, this is the moment we've been waiting for, the real test. How do we take everything we've done so far and actually use it to help students? The best way to bring all this skill extraction and mapping to life is through an AI assistant, one that students can talk to, ask questions, and actually get practical, personalized help from. So let me show you how this works. Here I've created a custom GPT that's trained on a specific course, Politics of the USA. The main goal of this assistant is to help students understand what skills are involved in each assessment item, and then recommend the right support services to build those skills. Let's walk through a scenario. Say I'm a student in this course, and there are 4 different assessment tasks throughout the term. I've got one coming up, the research essay. And honestly, I'm not really sure how to prepare for it. I've read the assessment description, looked at the learning outcomes, but it's still not clear what I should focus on. I think I need academic writing and maybe some research skills, but that's about it. So I ask the AI assistant for help. First, it asks me which assessment I'm working on. I select Research Essay. Then, the assistant gives me a breakdown of the key skills I'll need for that specific task and how to get started. Here's what it told me. The research essay in the course requires strong research and writing skills, but not just in a general way. It highlighted specific areas like independent research, critical evaluation, historical analysis, academic writing, and making connections between historical trends and current policy debates. Then it walked me through some prep steps, understanding the essay question, gathering credible sources, developing a thesis, creating an outline, and refining the final draft through editing. That alone is already super helpful. But the assistant didn't stop there. It also offered to recommend support services relevant to this exact task. And this is where it really shines. Instead of just throwing a list of links at me, it explained why each service would be useful. It suggested the academic language and learning support for help with essay structure, building a clear argument, and referencing properly. It pointed me to the course convener for clarification on the essay topic, course expectations, and research direction. And if I'm juggling a bunch of other responsibilities, it recommended the postgraduate support service to help with research strategies, choosing a manageable topic, and managing my time effectively. So in one conversation, the assistant took a vague assessment description and turned it into a step-by-step plan with skill insights, preparation tips, and tailored support recommendations. That's what makes this so powerful. It's not just about extracting skills. It's about using them to guide students in a meaningful way. All right, let's try this out with another assessment, tutorial participation. Now, I think we all know that just showing up isn't quite enough. A good student actually contributes, asks questions, engages in the discussion, brings in ideas, and interestingly, the course outline really backs that up. This assessment is linked to 4 different learning outcomes, ranging from having a broad understanding of U.S. politics to critically evaluating debates, doing independent research, and writing academically. So, when I asked the AI assistant about this task, it went straight to work, pulling relevant skills based on those learning outcomes, but tailored specifically to what's required for this assessment. The response made a lot of sense. It explained that tutorial participation in the course involves more than just talking in class. It requires critical thinking, understanding both historical and current political influences, a solid grasp of U.S. institutions, independent research, and yes, academic writing too. The assistant then grouped these into 2 main skill types: cognitive skills like research, analysis, and problem solving, and soft skills like communication and discussion. So far, so good. Then, naturally, I asked, how can I get help developing these skills? And yep, the AI delivered again. It quickly suggested a few relevant support services that could help boost participation. Without going into too much detail again, it pointed me toward academic skills workshops for help with argument structure and critical thinking, some practical strategies from the postgraduate support team, and reminded me that the course convener is always a great source for feedback on how I'm engaging in tutorials. Finally, let's try something a little different, something that involves media creation. Let's see how the AI can help with a video presentation. Now, in this case, the course doesn't give us much to go on. There's not a lot of detail about what the task actually involves. And honestly, that's pretty common. But this is exactly where Gen AI proves its value. It took what little information was available and inferred the kinds of skills students would need, not just to handle the technical side of producing a video, but also to meet the deeper learning goals of the course, like critically analyzing political issues. So here's what it came up with. The AI explained that the video presentation assessment requires a blend of research, communication, and technical skills. It listed things like video editing, public speaking, critical analysis of political topics, research and synthesis, storyboarding, and the effective use of visuals. Then it broke these down into categories: workplace skills like communication and teamwork, cognitive skills like research, critical thinking and problem solving, and industry-specific skills like media production and design. Honestly, that's a pretty well-rounded skill set. And of course, when it came to support services, the AI nailed it again. It recommended help for developing strong arguments and presentation skills, support for staying organized and managing time effectively, and guidance on the political analysis side from the course convener. It even gave direct links for booking appointments and digging deeper. And just like before, the assistant didn't just throw names at me. It explained why each one was useful for this particular assessment. Even with limited information, it pulled out the key skills, matched them to the right support, and gave the student a clear way forward. So now that we've seen how this works across a range of assessments, from essays and tutorials to media projects, let's zoom out and talk about the bigger picture. What's the real impact of all this? In a word, scalability. That's where this work truly shines. Large language models like Gen AI give us the ability to scale this kind of support in a way that just wasn't possible before. One of the big advantages is how well LLMs handle variation in language. They can recognize when two skills are essentially the same, even if they're described differently across courses. So, for example, one course might ask students to critique a research paper, while another might ask them to evaluate sources. The wording is different, but both are really asking for critical thinking. By grouping these kinds of similar skills under broader categories, we can spot patterns, like which students are struggling with the same core skill, even if they're in completely different subjects. That means we can offer targeted support, say a critical thinking workshop or one-on-one help, without needing to build a custom intervention for each course. It also means we can use our support resources more efficiently. Instead of running separate programs for every course, we can create cross-course support that serves a wider group of students. It's smarter, more sustainable, and ultimately more helpful for students. So this isn't just about making AI look clever. It's about using AI to amplify the support we can offer, reaching more students earlier and with the help they actually need. So, to wrap it all up, this whole project is a great example of how generative AI can enrich our understanding of student learning and actually turn that insight into action. Starting with something as unstructured as a course outline, we were able to extract meaningful assessment-specific skills and organize them into a structured, well-defined taxonomy. And once we had that foundation, everything else became possible. We could connect those skills to the right support services, not just randomly, but in a way that's targeted and meaningful. Even better, the AI didn't just recommend a service. It could explain why that service was useful for a specific assessment and the exact skill a student needed to build. That's the part I find most exciting. It's not just about handing students a long list of generic resources. It's about helping them understand where their skill gaps are and giving them the confidence that they're focusing on the right things and getting the right kind of support to succeed. This is how we move from information to impact. And we're just getting started.